In this demonstration, I'll show you how to plot a cosine function containing an amplitude and a phase shift. This will be question 2 of this series. The first thing that you have to do when it comes to graphing a cosine function or even a sine function is you have to determine your A, B, and C value. Your A value is your amplitude, your B value helps to determine your period, and your C value helps to determine your phase shift. Your A value, in this case, will be the absolute of -5, which is equal to 5. Always take the absolute. These two lines represent the absolute, so if that were negative, it becomes positive. Next, your B value is the number that is in front of the variable. In our case, the number is 1. So don't make that mistake. There is a phantom 1 there. Don't make that mistake into thinking that your B is nothing. And lastly, your C value is this number right here, 7 pi over 5. And this number is significant for several reasons. But in our case, it's significant because it is in radians. And since it's in radians, our whole equation is configured in radians. Therefore, we will be using this formula to find our period. So let's go ahead and find our period now. Period is equal to 2 pi over b. Now our b value is 1, so I'll replace this b with 1. And that gives us an answer of 2 pi. So one full cycle of this wave will take place within this range, 2 pi. That is your period. Next, what we will do is we'll find our phase shift. Now our phase shift is this formula right here. So I'll represent phase shift with PS, and it's -c over b. Our c value is determined up here, so I'll replace our c value, 7 pi over 5, and our b value was 1. That makes it easier for us. So therefore, our phase shift is simply -7 pi over 5, which means that every point you plot will be shifted -7 pi over 5. Now you'll notice in our graph you have these points here leading to the period, which I'll represent as P. To find out what those points are, it's really imperative that you do this. You have to divide your period by 4. And if you divide your period by 4, you end up with pi over 2. Because 2 divided by 4 is 1/2, and there's a 1 right there. So these points will represent half, 2 pi over 2, and 3 pi over 2. And I know what you're thinking. This is equal to pi. So I'll replace that with pi. The next thing that you want to do is you want to graph cosine. Now, we know that cosine starts at 1 when the amplitude is 1. In our case, it's -5. But it starts at 1, and then just follow my mouse here. It starts at 1, it goes down, and then reaches a low point midway through its cycle, and then it goes back up. So let's do that, but instead of using 1, let's just use 5. 1, 2, 3, 4. Now, of course, these are 4 boxes, but you can space them out as you wish. So now what I will do is I will plot cosine without a phase shift. And I'll use a dashed line so you can follow along. This is what cosine would look like. There you have it. That's what cosine would look like if it had an amplitude of strictly 5. Now you'll notice that our A value is -5. Now what that means is that our whole wave will flip. So this point will be here. This point will stay the same. This point will be up here. Sort of like the mirror image. This point stays the same and that point goes down here. So let's recreate this with that negative in mind in our A position. Wonderful. The last thing that you have to apply is the phase shift. The phase shift tells us how much each one of these major points will shift. In our case, the phase shift is negative. Since the phase shift is negative, that tells us the direction. That means that every one of these points will shift to the left by this amount. So, how do we do this? First of all, let's find out what that is equal to. 7 pi over 5. 7 pi over 5 is approximately equal to 4.39. And let's find out what that is equal to. Pi over 2 is equal to 1.57. Now, given that our graph is really small, this is going to be a little bit problematic for us because let's start off here. We know that this point is going to shift to the left by this amount. So let's use our calculator to find out how much that is. 7 pi over 5. And let's put brackets here so we don't make any mistakes. And that is equal to 10 over 7, which is equal to 1.42. Now, if you recall, this alone is 1.57. So the distance from the origin to here was 1.57, which we determined earlier. What that means for us then is that this point right here, is actually going to be shifted way past that first turning point. Now that's problematic for us because we don't have the real estate, if you will, so this point right here, to draw that out. That point will be right there, so it's going to be a major shift here. And I'll do my best. This point, sorry, I think we were using the blue. The blue is what represents, so this point right here would be over here. And this point would be way, way past the viewpoint. So it would be somewhere here. Let's make sure that we're doing, so that's 1, 2, 3. And so this one would be 1, 2, 3, and a little bit, so it would be right here. So you notice the dilemma of our problem here, and then this would be connected, and then eventually it would make its way up here, and you get the point, I hope. So technically it would be shifted a lot. Now, due to the nature of our equation, of course, this is not usually going to happen when you are given a question like this on a test. It will be within the frame of the graph that's provided. Hopefully this video helped you out and gave you an understanding and an idea of how to graph a cosine function. If you have more questions, use our other video, part 1, which showed another example, but with degrees rather than radians. If you have any other questions, use our website at biology-forums.com. See you soon.